All right, we're going to end it on this one, the end of chapter 4 in your complex numbers. So we're going to do some more examples of a complex root, or an example. I'm going to follow your homework pretty closely here and give you something very similar to what you're going to be doing. Just the way you could maybe match it up and do your own individual problems. And I think this one might be taken to a little bit of a level that's above what you're going to have. But there's always variation. Let's go. So there's our formula, or the way in which we're going to find all of our roots. And the question we're going to ask here is, let's find the fifth roots of this complex number. Z is equal to 2 times cosine of pi over 6 plus I sine of pi over 6. So this is already set up into trigonometric form, which is nice. You're going to have one in your homework that's going to start off that's not in trigonometric form. You're going to have to get a trigonometric form and then do this whole process. So that you'll have one additional step at the beginning. I think that's going to be your last problem in your homework. But this one's already set up for us in trig form. That's what we want in order to use our formula. Excuse me. All right, since we're finding the fifth roots, that means that we're going to have 5 answers, 5 unique fifth roots of this complex number. Yeah, there's an I in there, so, well, gotta be a complex number. Okay. Before we get started, let's just write down our variables. A couple of them that we already know. Like n. It's however many roots you're taking. Right? Whatever root you're taking it to. So we're taking it to the fifth root, therefore, n is equal to 5. You're also going to have an angle. And this one's given to you because the problem tells you what the angle is. Where's the angle? There's only one freaking angle written in the question. And that's pi over 6. These things won't change in our formula that we're going to use to find 5 answers. Those are going to remain the same. Those are going to stay constant. The only thing that's going to change in our formula is going to be the k. But the first thing we do is we want to come up with this formula with the k in it. And then once we have that, then we can plug in k equals 0, k equals 1, k equals 2, all the way up to 4. All right, we're going to have to plug in k equals 0, 1, 2, 3, and 4. And find answers for all of them. If you look at there, that's actually 5 answers. So you never go up to the number of the root. You go to one less, n minus 1. N minus 1 is going to be 4. All right, let's set up our formula. So I have it down here, just kind of generic. Oh yeah, what's our radius? Our radius is that number there. I forgot to define that one, huh? The radius is equal to 2. So let's start plugging things into our formula. I look up here and it's r to the nth root. Well, our n is equal to 5. So it's the fifth root of, and our r is equal to 2. Cool. So we got that part taken care of. And that's going to stay. I know it's not a cool number. Don't punch that into your calculator or anything yet. Just leave it. Fifth root of 2. Okay. I don't know what it is. It doesn't break down. Doesn't get any simpler. Just leave it there. It's going to go along for the ride in all of our answers. You're going to have this fifth root of 2 sitting at the beginning of it. Don't stress about it. Just let it go. Just make sure it's there. The tough part is going to be the arguments of cosine and sine. So let's set it up. All right. So it tells us theta first, right? Theta, well, we know theta. That's pi over 6. And then we're going to add it to plus 2 pi k. Well, the 2 pi, that's remains the same, but that k, that's that thing that's going to change. That's going to change. And then we're going to divide it by n, but we know n. N does not change. The only thing that's going to change is our k once we get our formula. So let me put that in purple as well. And then we're going to write the same thing in over new sine. Plus that 2 pi k. We now have a formula we can plug our k equals 0, 1, 2, 3, and 4 into, and to get our solution. So let's follow the way that the homework's going to do. And it's going to ask you first for the exact answers, which means not punched into your calculator, but just kind of cleaned up. Now, the work is all done right inside of the arguments. This is algebra, but it's not super simple by plugging them in. So you want to try and catch the pattern. We're going to do this 5 times. I don't want to do it more than 3 times. I want to catch a pattern by the third, and then I can just plug in for 4 and 5. That's a beautiful thing about trig, is it repeats and has lots of patterns. I like to do less work, not more work. So let's start with k is equal to 0. Okay, and there's some simplifications you could do aside to this if you wanted to, but I'm just going to run it the way I believe most people are going to do it. So let's go find when k is equal to 0. So we're going to have that fifth root of 2. That's not going anywhere. And we have cosine of pi over 6 plus 2 pi times something divided by 5. Now what's that something? It's that k. It's 0. So that 2 pi is just going to go away. This whole piece is just going to disappear, and you're going to have pi over 6 divided by 5. That pi over 6, and it's always the same thing over here as what you wrote inside of cosine. And so you just have to write it showing you know what's up. And now let's simplify, because again, 2 pi times 0 is 0. What do we have? This is the fifth root of 2 times cosine of. So we have pi over 6 divided by 5. All right? Pi over 6 divided by 5, because those 2 pi times 0 just went away. Nothing to mess with there. So this is equal to pi over 6 times 1 over 5, which is equal to pi over 30. Okay, neat. Pi over 30. Now I don't even need to look at the other one. I know it has to be the same. It's pi over 30. And there we have it. There is an exact answer. So this is how the homework is going to ask you for your solutions at first. It's going to want you to go through and go find the first root, or for 0, 1, 2, 3, or 4. I think I only give you up to the third root in your homework. I'm not making you do a fifth root. I don't believe. I might be. I don't know. So there we go. There's our first one. And eventually you're gonna need to evaluate it in the second part. So you're gonna have to plug that thing into your calculator. Make sure you are in radians. I'll do a couple of them when we end, but I want to go in the same pattern in which your homework goes. So once we have 0, we need to move down to 1. And this is where that's going to get just a bit more tedious, because we're going to have to add some fractions here, huh? And now we're multiplying by 1, so that 2 pi doesn't go away. That 2 pi does not go away, so we're going to have to be doing some work in there. Now we write the same thing. I'm not going to keep color coding though. 2 pi times 1 all over 5. So let's jump aside and let's do that. Let's take pi over 6 plus 2 pi times 1. I'm not going to write it here. Over 5. The first thing you need to do is find a common denominator up top. You need to put these two things together. And I hope at this point you know that 2 pi is the same thing as 12 pi over 6. 12 divided by 6 is 2, right? So 2 pi is the same thing as 12 pi over 6. So let's add them up. We get 13 pi's over 6 divided by 5. What's 13 pi over 6 divided by 5? Oh, that's 13 pi over 6 times 1/5 for 13 pi over 30. We have our second solution. Oops, why did I write 2? Because I said second, and that makes my brain think that that should be 2, but it's not. It's always 1 behind. So we have cosine of 13 pi over 30 plus I sine of 13 pi over 30. Here is our second exact answer. Now, I know the trick. So at this point, I could just write down the rest of my answers. But you don't know the trick yet. I'm going to let you in on the trick so you can save some time. What is the difference between 1 pi over 30 and 13 pi's over 30? What's the difference between 13 and 1? It's 12, right? I know that we're just going to add 12 pi to the numerator every time. So the next answer is going to be 25 pi over 30. We'll reduce that thing down. We'll get a little different of an answer, but that's just going to be the game. For each 1. All we're going to do is add 12 pi over 30 to our answer. That's the gap between the two. So let's see it in action. So I'll do the next one just the normal way. And then maybe you can see if I'm correct if I got 25 pi over 30 just by adding another 12 pi over 30 to that. Let's see. I don't know. I could be wrong. You know what? I haven't done this literally since grad school. That's a long time ago. Like 7 years, 8 years, something like that. Cosine of plus I sine of. All right, and we're gonna have to plug all that crap back in. So we're like pi over 6 plus 2 pi times, and now we're at 2, so we're gonna multiply by 2, all divided by 5. Pi over 6 plus 2 pi times 2, so 4 pi. And let's jump over to the side and let's do that one as well. Let me get rid of all my work from over here. See if we can't figure something out. So, oh, that was 2 pi. But now we don't have 2 pi. What's 2 pi times 2? 2 pi times 2 gives us 4 pi's. Then when we do 3, you'll get 6 pi's. So it's 4 pi. So we're going to need to get a common denominator one more time. Fortunately, 4 pi, isn't that 24 over 6? 24 over 6. So it looks like we have, what's 1 pi over 6 plus 24 pi over 6? Isn't that 25 pi over 6? Wait, did I say something about 25? Nah, that was probably coincidence. Divide that thing by 5 and then flip it over. I'm doing this over and over because I just looked at your dang midterms and I was like, man, y'all struggle with dividing. So writing it out old school. So you get 25 pi over 6 divided by 1 or times 1/5. You get 25 pi over 30. That was 12 more pi's over 30 than 13 pi over 30. But of course, this simplifies down to 5 pi over 6. See the pattern. See the pattern. Oops, stop writing the next number. I just want to just jump to the next one. So this is the 5th root of 2 times cosine of, and to be exact and to be reduced, we write in 5 pi over 6. But you and I both know it's 25 pi over 30. There's our next solution. But now I'm going to cheat. I don't want to continue doing this. This is crazy talk. I know that the next one, I'm going to be like, all right, it's the 5th root of 2 times cosine of, and now I just want to look. I went from pi over 30, and then the next one was 13 pi over 30, and then the next one was 25 pi over 30. So now I just want to add 12 more pi's to the numerator, right? That's all it is. The difference between pi and 13 pi, 12 pi's. Difference between 13 pi and 25 pi, 12 pi's. So if you add 12 to 25, you get 37 pi over 30. Bang, got it. I no longer have to continue doing this. I like to recognize patterns because I'm really freaking lazy, I'm telling you. And now we have another answer. And we have to do it one more time, and let's see if we can't just write it right below. So that one is the 5th root of 2 cosine of, what's 12 plus 37? 12 plus 37 is equal to 49. So we get 49 pi over 30 plus I sine of 49 pi over 30. 1, 2, 3, 4, 5 answers. Woo! And those are all exact. Now in your WebAssign homework, you're going to need to plug this into a calculator. Now I'm only going to do the first one. You can plug stuff into your calculator. So we're going to say that our Z naught, first one we found, we now need to make sure our calculator is in radians so we don't get the wrong solution. We'll go through, and in the calculator I want to hit, I'm going to cheat and say 2 to the 1/5 power because, well, I'm a jerk in my calculator. And now I'm going to multiply it by, now make sure you use your parentheses here, huh? When you do your cosine of 49 pi over 30 plus I sine of 49 pi over 30. You know what I mean? Know what I mean? All right, be careful. So cosine 49 pi divided by 30. I get 0.0406. So no weight on this one actually. Let's kind of got ahead of myself. So 0.4067. I'm just adding extra ones in. And then we're going to have the number times our I. We need to plug that into our sine function as well. So sine of 49 pi divided by 30. Get a negative 0.9135. Now distribute that stuff in. So you're going to take them and, I don't know, you can use your rounded answers, I believe. I don't think anything crazy is going to happen. I think we should be fine. So 0.4067. And I get 0.4672 plus, oh, that's going to be a minus. That's going to be a minus. And now we punch this in. And now I'm going to do the 5th root of 2 times that rounded number. So 2 raised to the 0.2 times negative 0.9135. Woo! Minus 1.0493i. And then you're going to have to go through for all of them and write in what they are. I know it's going to be long. It's going to be tedious, just like this video. We're at 16 freaking minutes. We're over 16 minutes. Yeah, dude. They're long, and you have a few of them to do, but the only way to learn how to do this is through practice. So my apologies for all the tedium. Hopefully by the time you've done enough of them, by the time you get to your final, this should be not a problem. Have this written down on a sheet of notes so you can follow this pattern. You know what I mean? Don't get blindsided by it when it's on your homework or in your final. But I most certainly would not be asking you any 5th roots. You can pretty much guarantee it's a square root or a cube root. All right. See you in the next section.